Hello everybody. So let's attempt to answer this question, which is question 4 of the September 2020 trial exam question paper. So here a bullet of mass 5 grams is fired into a block of wood of mass 1 kg that is suspended by 2 light strings. The bullet is stuck in the block and the block bullet system swings up to a height h. The height h is 50 centimeters. All right. So here we're given a bullet, a small bullet of 5 grams. So the first thing that we need to do is to convert this mass to kg. So it's going to be 5 over 1000, which will be 0.005 kg. Then we also need to convert 50 centimeters into meters, so it's going to be 50 over 100, which is 0.5 meters. All right, so here we have a bullet, and this bullet is fired. All right, so we have a bullet which is fired into a stationary wooden block of 1 kg. So the bullet is fired with an unknown velocity, and this bullet is fired into a stationary wooden block. So this bullet have a momentum because it possesses a velocity, and the wooden block is stationary, so it does not have momentum before the collision. All right. So after the collision, after the bullet has collided with the wooden block, so it stays inside the wooden block after the collision. So in other words, the mass of the wooden block and that of the bullet will combine, and this is and the two of them will have a unique velocity or one velocity. So because there will be one system, there will be a unit system with a unique with one velocity. So if we can formulate this mathematically, so this is the momentum of the bullet initially plus the momentum of the wooden block initially before the collision. This will be equal to m1 plus m2 times velocity final. So this is before the collision, this is after the collision. So this is the momentum of the bullet, this is the momentum of the block, but after the collision they will have the mass of those two objects will combine, and they will share the same velocity because they will be a one system. Okay, so after the collision, this is what is going to happen. So the bullet will stay inside the wooden block just after the collision, but after some time, so the bullet, the block and the bullet system will swing up to a height of h meters, which is 50 centimeters above from the ground. All right, as it is illustrated there. So when the bullet strike this block, so both the bullet and the block will move from the ground up to a height of h meters. All right, so let's attempt to answer the questions now. So 4.1. So 4.1, state Newton's second law in terms of momentum in words. Okay, so before we can even state it in words, let's first state this law mathematically so that it can be easy for us to transform from the mathematical form to the word form. So this is Newton's second law mathematically. So once we write it mathematically, it's going to be easy for us to formulate this in words. So what does this state? So F net is equal to change in momentum over change in time. So anything that is divided by time is the rate of change. So now if we state this law in words, now this simply states that the net force or the resultant force, so the resultant force, or let me use the net force word. So the net force, and this net force is acting on an object. The net force acting on an object is equal to the rate of change of momentum of that particular object. And this rate of change is in the direction of the net force. So that is Newton's second law in terms of momentum in words. So in 4.2, so we must calculate the velocity of the block bullet system immediately after the bullet enters the problem. But now the challenge here is that if we are to apply this law over here, or this principle, which is the conservation of linear momentum. So we don't know the initial velocity of the bullet, and now we are required to calculate the momentum of the bullet and the block after the collision, whereas we don't know the momentum or the velocity of the bullet before the collision. So we are going to have two unknowns. That means we need to exhaust another option. So what we can do here, so this one fails because we don't know velocity of the bullet, and we need to calculate another velocity. So we're going to have two unknowns. So we are going to apply energy principles, because here the fact that they given us the height, it's a hint that we must apply energy principles. So what does energy principles say? So the sum of the mechanical energy is conserved. So in other words, so mechanical energy initially is equal to mechanical energy finally. So what is this mechanical energy? This mechanical energy is simply equal to the sum of kinetic energy and potential energy initially. This should be equal to the sum of the kinetic energy and potential energy finally. And we know that kinetic energy is defined by half mv squared, and potential energy is defined by mgh. This should be equal to half mv squared plus mgh. All right. So this is the guy we are looking for. So after the bullet has entered the block, so we need that velocity. So it's half. So when the bullet enters the block, so the mass of the block and the bullet will combine, and they will have momentum. Those two masses will have the same momentum because they are a combined system. So we're going to combine that 0.005 grams and the 1 kg. So when you combine the two, it's going to be 1.005 times the velocity. We don't know the velocity after the collision, after the bullet has collided and entered the block. So what will be the potential energy? The potential energy will be 0 because the height is 0. So both the bullet and the wood, they are at ground. So mass times gravity times 0 will be 0. All right. So after some time, the bullet, the mass bullet, the block bullet system will reach maximum height, and the velocity will be 0 at maximum height. We know that from projectile motion. All right. So, but the potential energy will be maximum. So again, at that point over there, at 8 meters above the ground, so the mass bullet system, we need to combine the mass. So we're going to have 1.005 times 9.8, then times height, which is 0.5. So now this potential energy, this half 1.005 times v squared plus 0. So this 0 is not significant, so we can drop it. So we're going to have half 1.005 v squared is equal to this 0 is not significant. So we're going to have 1.005 times 9.8 times 0.5. Then we want to isolate this velocity. So we're going to divide by half 1.005 half 1.005. All right, so this and this is going to cancel. Then we'll have v squared is equal to this guy and this guy going to cancel. This half is equivalent to 0.5, so we're going to be left with 9.8. So if we want this velocity, we're going to take the square root of v squared. Then our final velocity, the velocity will be the square root of 9.8, which is 3.13 meters per second. So this is the velocity of the block bullet system at that point when the bullet enters the block, and they are both at ground. So they will have a bullet of 3.13 meters per second. Then in 4.2.2, 4.2.2, 4.2.2. So we need to calculate the speed of the bullet before it struck the block, just before the collision. So now we're going to apply the principle that we skipped earlier. So now, which is the law of conservation of linear momentum. So the sum of momentum before the collision should be equal to the sum of momentum after the collision. So the mass of the bullet times the velocity of the bullet before the collision plus the mass of the wooden block times the velocity of the wooden block before the collision should be equal to the mass of the block plus the mass of the bullet before the collision times the velocity before the collision. So we know the mass of the bullet is 0.005 times the velocity we're looking for. The block was stationary, so the velocity is 0. So the momentum is 0 because mass times 0 is going to be 0. So this mass is going to be 1001 plus 0.005 plus the velocity after the collision, which we quantified to be 3.13. It's 3.13. So we're going to have 0.005 VI is equal to 1 plus 0, okay, it's 1.005 times 3.13. This is 3.14565. All right, so let's divide by 0.065 both sides. 0.065. No, 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 no. 005, 005, 005. Then the velocity will be equal to the velocity of the bullet after the collision. So it will be 3.14565 over 0.005, which is equal to 629.13 meters per second, which does make sense because the velocity can have that, the bullet can have that high velocity. All right, so 4.3, the last question. So the mass of the block is doubled now. How will the height now reached by the block be affected if it was shot by the same bullet as before? So now we double the mass of the block. So now the mass of the block is 2 kg. So the same bullet which have that velocity strike this block of mass, which is now doubled. So how will the height be affected? Will it be greater than, less than, or the same? So remember, the height reached by the block bullet system depend on the force. So this force, okay, before we even talk about the force, so we have velocity, and once we have velocity, and this velocity does change because when this velocity hit this block, it will change. That means there is an acceleration or deceleration because there is a change in velocity. And we know, according to Newton's second law, F net is direct proportional to the acceleration. So, and inversely proportional to the mass. So, if the velocity didn't change, that means the acceleration is constant. And now we double the mass. Therefore, the F net should decrease. And therefore, the height reached by the block should also decrease because there is less net force which is applied. Therefore, the correct answer on 4.3 should be less than. It cannot be greater. It can only be greater if you have the mass. Yeah, that's all.